So let's say a new person join your team, and because he's a new guy, you do not want to give them a complete access to your Kubernetes cluster. So you just want to give him an access to just to list the pod. Okay. How you are going to achieve this one? So you guys understand the question, right? A new guy joins your team, and because you don't know about that guy, so you just want to get started and you just want to give him access to the command which we have done, that Kubernetes get pods, right? Yes. Are back. Are back. Back. There's something called role-based access control in Kubernetes. But before I'm going to explain the role-based access control, let's take a step back and let's go to the journey all the way how you run, person will run that command. So either via this tool or either I am going to run it via this, right? Basically, I want this guy to only have the permission to run this command. So I just want to walk through the journey, how this command is getting executed on the Kubernetes side and how you're getting the response back to your screen. Okay. So first thing is, you as a user, right? You are executing some kubectl command. Let's not go to the kubectl get pod. I'm just using a like a high level overview. You are using a kubectl command. Okay. Now the first thing which is going to happen is called authentication. Right? Now, some of you guys already know, or some of the guys you have never asked me how this is happening, right? Can anyone run this command, or some authentication is happening behind the scene, right? Like Kubernetes know if this guy is running that command, I need to give him an output. So anyone know who is responsible for authentication for Kubernetes? Or what exactly it is going to check for this authentication? I will not say key-based authentication is something else. Okay, let me put it this way. So for example, that username is Prashant, right? Who joins your team. If I run this command, this is going to work. Like in Linux, you have a command called user-add, or you are getting those users from some kind of like a Active Directory or LDAP or anywhere else, right? Or Okta. If I run this command, is this going to work? Yeah, you're right. This command is not going to work. But the basic idea is like not with Kubernetes, but anywhere, right? If I need to log into the AWS console, right? I need to give a username and a password, right? I need to give some username and a password. Then only AWS know that I am the authenticated user who has the access to access this particular service. So my question again here, like how does Kubernetes knows about all these things? Yeah, Mohit, agree. Okay. So there is two ways. Yeah, sorry, somebody wants to speak about it.
Yeah, Prashant. So usually we used key, asked to you to create a private key or public key, and sign the key with the same CA which CA is signed the Kubernetes cluster. So then the user is able to access the cluster on the basis of the role which we have configured.
Exactly. So that's what I want to heard, certificate. Key is fine, but that is something to do with the certificate. So basically what will happen is that the reason I'm able to run this command called kubectl get pod, because inside my home folder, there's a file called kubeconfig. And in this config, I have this key and data as well as certificate. Okay. So what will happen is that when a new user joins my company, what will happen? He's going to create something called certificate request, CSR. And then he's going to, I mean, that's a bunch of OpenSSL command. I don't want to go into it. and then he's going to send it to the cluster admin. Okay, and in that CSR, he's going to generate. He's going to specify the OU and a user. So let's say the user they have specified is called Prashant. Okay, that is one way. But let's say my company has like thousands of users, right? In my case, it's like 16,000 users. So we are not going to generate a certificate for each individual user. I know these are the admin users, these are the set of users who is going to perform these actions. So basically in that certificate request, CSR, certificate signing request, we have a group. So let's say I have a group called DevOps group. Okay. So this, they are going to create a this certificate signing request, and this is going to be configured, or the key or the certificate that we are going to generate out of it, the key we are going to generate out of it is being signed by the Kubernetes cluster or the Kubernetes server cert. Okay. So basically you can think of it like this. This CSR, which this guy is going to generate, they will mention the group, for example, the DevOps in the OU. And at the Kubernetes at server level, we are going to validate that. We will say, okay, yes, now this guy can use this certificate or key. And this is how this guy is going to authenticate. Okay. Now coming back to your pod, the way your pod works, for example, we can take an example of any of these pod. Now let's run something called describe, right? And if you scroll down, where is that? Mount, right? You see this line, where runs secret Kubernetes IO service account. So like I mentioned, in Kubernetes case, there is no concept of something called a user. You can use it. For example, in case of AWS, you have something called IAM, right? And they have some kind of a connector, which is called IAM role for, they called it IRSA, through which you can use those IAM user, or you can integrate it with third party. But Kubernetes does not have a native concept of users. So in case of Kubernetes, you can do something called create something called service account. And those service account you can mention in your pod definition. And depending upon whatever the permission that service account has, that user will be able to do it. Okay, so I can give you an example how that is going to work. So here I can search for service account. And please remember this kubernetes.io/doc. This is super, super helpful. So when I'm defining my pod definition, I can specify this service account. Okay. And the way I can create a service account is pretty simple. I will say create SA, and then I will create Prashant. So this service account is created. One more thing before we move to the next part, authorization, the RBAC one. If you see that right now I'm running the Kubernetes 1.27.3. And if I try to do the describe essay for this Prashant user, you see there is no token associated with it. So from now onwards, you need to create a token for this particular user. And I will tell you what is the significance of that. So, okay, let's do it over here. Kubernetes get pods. Sorry. Okay. And once again, we will do this one. Kubernetes describe pod. And I told you that the service account which has been created is been mounted inside this particular directory. Okay. So let's say kubectl exec -it and this one, and I need to give a pod ID. I will tell you what exactly I want to show you guys. Okay, so basically this is a token which is being generated, and based on this token, this pod is getting access to the API server. Okay, and this has been coming from the default service account which has been created along with your cluster. So you need to have some user who has access to call the API server and get the information. And that is being done with the help of like authentication layer. Okay. And one more thing I want to show you before, if you copy this, and this is a JWT token here. Yep. So if you earlier, if you see any account which is created, I think before Kubernetes 1.2.5, they do not have any expiry. But now starting from 1.2 or 1.25, I don't remember, your service account has expired. That after this particular amount of time, your service account is going to expire. So there are ways to renew it, the lease, but that's a separate topic, but just want to throw this idea. But if you do not understand this, just remember that in Kubernetes, there is no concept of accounts. In order for your pod to have access, you can have the service account. You can create a service account and give that service account access to do some operation. Now, how that service account is going to do an operation, that is being controlled something called RBAC. kubectl create RBAC, right? And here you can do, oh, sorry, it's not RBAC, it's called role. So here you can define create role, whatever the role name you want to provide. And verb is something called get, whatever the operation, list or watch. And for what resource you want to give that permission, right? So verb and resource, that's the most important part. So we have solved the first part of a puzzle. We have given, like we have created a role with defining with these kind of a permission which we want to give. But whom we need to assign this permission, right? For that purpose, you have something called role bindings. And in the role binding, you can define, for example, role binding, the name. Let's look at this example, the role that you have created in the previous step, and you can define the service account that you have created. And that service account, you can then specify in your pod specification that this service account, whatever the role you have defined that this account is can only do the list and get operation, that service account will get that permission. So we have this authentication, which is performed by the certificate. And then we have this authorization. Just really quickly, I want to show you something called admission controller. Once again, I will run, for example, Nginx, image equal to this one. And this time I want to introduce a new concept called namespace, right? I want to create a pod named Nginx. Okay. Let's say, let's give it any name. Okay. With the image Nginx in a namespace called test. Okay. How many of you guys think that this command is going to be succeed? Or how many of you think this command is going to fail?
You need to create the namespace first.
Exactly. So namespace test not found because this namespace does not exist. Now, David, do you know why this command failed? And is there anything in Kubernetes which is checking behind the scene like, okay, the namespace should need to be exist before we execute this command? So that's where the role of admission controller take into place. So under the hood, they have called something called namespace exists admission controller. What this will do, it's going to see if the particular namespace exists or not, and then only allow your pod to create that particular uh, 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 I mean allow your pod, I mean creation of your pod if that particular namespace exists. There is also called namespace auto provision. So in case if your namespace does not exist, it will automatically create it for you. But that controller is not enabled by default. Okay. So I mean, just want to give you some information about these are the things which happens under the hood. I know we are 3 minutes over time, but just want to show you two more things quickly. So, I mean, so far, whatever we have seen, it's fine, right? Like this guy exists, that guy exists. But one of the most important thing of admission controller is to enforce something. So in this case, we have seen that if the namespace does not exist, it will throw an error, right? That namespace does not exist. But in case of production environment, if you look at here, if I remove this one, right, and if I try to run that, this is going to create a pod for me, right? And this, what it is going to do, like we have seen in the case of a Docker, if there is nothing specified after that, it is going to pull the latest image, whatever it is present on the Docker hub, it is going to pull that latest image for us. Okay. So we need to enforce some kind of an enforcement that, okay, if this never pull an image from latest image from the Docker hub, or let's say in my organization, we have some private registry, right? Most of the organization, I'm pretty much sure that none of the organization or the large organization, they pull image directly from Docker hub. So we always have some kind of a private registry from where we always pull the images, right? But how to enforce that, right? We do not want a user, we want to block a user who is trying to pull an image from Docker hub and who is trying to pull the something called latest tag. So how that is possible? So for that purpose, we have something called at the admission control level, we have something called OPA, or something called Open Policy Agent, where you can define the rule. So let me show you something called OPA Playground. And unfortunately, this language uses its own syntax or the own programming language called Rigo. So let me try to explain it to you as simple as possible. So what exactly this is doing, just look at this one, this line. So in case, for example, in your local organization, you have something called example.com. And if anyone who is trying to pull an image except for that example.com, that is your private registry, just block it. If anybody wants to create a container, so for example, if you integrate your admission controller with the OPA, and after that, if anybody is trying to pull an image, not start with, then it will say throw an error comes with the untrusted registry. In this way, you can enforce, almost everything with the help of this OPA. And if you do not want to learn this Rigo language, there is a project called Kubernetes, where you can specify all these things, but more in a Kubernetes way. Like, for example, you have the API version, you have a kind, you have a metadata, you have a spec. So this is a new project where you can specify all these policy, but mostly in a Kubernetes format, like the way this, like Kubernetes, this one. Okay. So one example is like, for example, if you do not provide a label to the particular pod, it will not allow you to create the pod. So just want to throw some example that after authentication authorization, there is one more layer called admission controller, which, at least if you are a beginner or intermediate level, you do not play with it. But in most of the organization, they used to have this admission controller, which is integrated with OPA and other thing. And this will enforce any rules because, okay, you will be able to create something, but you need some kind of an enforcement so that people will not create any containers or any pod in your organization. Any questions so far?
Prashant, I just want to know which one is good to use, or uh, like OPA or Kevin, which one is more preferred from your perspective?
So Mohit, I work with different consulting firms for this, and Kubernetes is something new. OPA has been there for a long, long time, and OPA is not only for Kubernetes; it is for other thing also. Like you can implement it for your own project also. So if that is your requirement, you can go with that OPA. But in case if you want to do something strictly within the Kubernetes world, or you want to use something which is Kubernetes native, like you want to define your definition like this, then go with Kubernetes. Let you go. Just one last thing I want to show you really quickly. So last time we have discussed that one of the Docker best practices is that any image which we are pushing to the Docker Hub, or any image we are pulling, we need to scan that. And last time I showed you there's something called Docker Scout, which does not work last time, but I tried my best and tried to make it work this time. So if you go to again to this Docker desktop, there's something called Analyze Image. And it will show you all the vulnerability which is present in this packet. See, like 212. Okay. So this is something you can do at the Docker desktop level. But there is one more tool which I used in my environment, or I have seen people they are using it. It's called Trivy. So Trivy is a tool which is from a company called Aqua Security. And the way we are using it, or most of the company they are using it, is Trivy, or there's other called Sync, which most of the people use, is via your CI/CD pipeline. So if anyone who's trying to push an image to your local registry, before that, Trivy is going to scan your package or your container, not container, the image, and only if it does not have any kind of a vulnerability, it will allow to push that image to your registry. Okay, and the way the Trivy scan work is simple. So Trivy image, let's say I want to scan the CentOS one. And installation is pretty straightforward. You just need to go to their website, and it's a one-liner. And they have like a repo, this DB repository, where they have already been, I mean, based on the research, they already have the database through which they are going to see the existing image versus whatever in their database, and they will tell you like this particular image has this kind of a vulnerability. Okay, so you see that this image, for example, CentOS 1, oh, wow, these many vulnerabilities. 271. Oh, total 485, sorry. 183 low, medium, high. Okay. So the way I have used Trivy is I usually do this flag called -- severity, high and critical, because these are the two which I am highly interested. So I can use it like this, Trivy image -- severity. And then I know at least these are the one which I need to fix as soon as possible. So basically, Trivy is a kind of a gated thing. So before I'm going to push the image to my local registry, I should have, or even they have something called a GitHub action for this one. So before you try to push the image to that particular location, or sorry, not location, to a registry, Trivy is going to scan it. And only if there is no, let's say, severity of high and critical found, then only it will allow the image to be pushed to your Docker registry or whatever registry you have internally. So that's what we have discussed is last time, that, okay, we can scan it, and Docker Scout is just for this Docker desktop. So I don't know how scalable is that, but Trivy is something which you can implement it at any level. You can implement it at a GitHub action, and you can see that this is just a simple command which you can run it in your Jenkins pipeline. Okay, so just give it a try. It's pretty simple, and it will give you a wealth of information. Similarly, even you can scan a Docker container with the help of a Trivy. I have used it. So if you have a tar of your Docker container, you can just scan it with the help of a Trivy. So not only the image, it can even scan that your container also.